Okay, we've seen that the integral of nx minus my with respect to area at least is plausibly equal to the line integral, the integral you get when you sum the m values with respect to distance along this edge and this edge, and add that to the sum of the n values as you integrate or sum up the n values along this edge, then along this edge. So I want to just, for the moment, focus on the contributions of the m values. Okay, so we recall that this number, which is the sum of your m values as you go this way along the lower edge of the rectangle, and the magnitude of this value, which is the magnitude of what you get when you go along here, those magnitudes are different. Now, if m wasn't changing with respect to y, then the values of m along this edge would be identical to the values along this edge, and since you're moving in the opposite direction along this edge, the sum of the contribution of m along this part of the line integral and the sum along this part would be 0. Okay, your line integrals from here to here and from here back to here would be equal and opposite. You'd have no difference. But m is changing with respect to y. Okay, we have an average value of my here that's approximately negative 1.67. And that's what causes this to be less than this. Similarly, it's the fact that the value of n changes with respect to x that causes the magnitude of this contribution to be different than the magnitude of this contribution. And let's, I don't have, yeah, here it is. Okay, so magnitude of this number is different than the magnitude of this number because n is changing as x changes. So there's a clear connection between the average rate of change of m and the average rate of change of n, and the differences between the contributions of the lower edge and the upper edge, or between the right edge and the left edge. And if you sort all that out, and it's easier to do that with notation than with numbers, we're going to do it with some notation, it makes perfect sense that the line integral of m with respect to x, which would be this contribution and this contribution, and n with respect to y, which is this contribution and this contribution, should be equal, or should be related at least, to these rates of change. Again, the integral of m dx is non-zero, would be 0 if m wasn't changing with respect to y, because again you have the same numbers down here you have up here going in opposite directions. And I've lost my sentence, but the integral of m dx is non-zero due to the rate of change of m as y changes. Okay, so you have a contribution here and similar contribution to the line integral, or similar influence on the line integral due to the rate of change, or the fact that n changes as x changes. Okay, so that's kind of the idea. And now instead of talking about numbers and so forth, let's go to symbols, because at least it's easier for me to think through this in terms of symbols and to express the exact relationships.